Hello, welcome back. I hope you had a good weekend. So we finished up our circles unit and you've taken your practice test. If you have not taken the practice test over the circles unit, don't watch this video yet. Go ahead and take that on Mastery Connect, and then you can come and check and go through this video with us. So we're going to go through the solutions to the practice test. So we will not be taking the test. We just did the practice test because of the whole situation. So if you are behind and you're watching this video further down in the future, that's okay. Just keep working at your own pace where you'll get caught up. So we've got about 3 more weeks left. I'm going to teach you 2 more units over surface area and volume, which will actually go by pretty quick. We used to have them as 1 unit and we broke them down into 2. So just think of it as kind of like 1 big unit, but we will do 2 separate practice tests for that as well. So make sure you get caught up. I want you guys to I know even though you guys have A's and this stuff isn't for a grade, so some of you guys are like, if it's not for a grade, why do it? Well, we don't just do things for a grade. The whole point of school is actually to learn the material and to learn the stuff. So even if you have an A in the class, that was for the 3rd quarter, you still need to know the last 25% of geometry. And a lot of the stuff shows up on the ACT as well. So join us. All right, so on number 1, you can see 26% of us miss this one. It says, what's the measurement of arc CDE? So first thing we want to do if we're marking out an arc CDE, notice how this one has 3 letters. Just like it takes 3 points to define a plane, it takes 3 points to define a semicircle or a major arc. So in this one, we go C, D, and E. So we start at C, we go the shortest distance to D. So we're going to go clockwise instead of going counterclockwise all the way around. So C, D, and then we're going to end up at E. So that's going to be this this arc right here, C, D, E, the blue one. And the question we have is, what's the measurement of that arc? Well, if you remember, we measure the arcs by their central angle. So we need to find the central angle, which is going to be this part here. Well, they gave us 46 and 100, and so the next thing we need to do is find the missing part here. Well, to do that, we need to notice that BAE, Bay, kind of funny, is a semicircle, right? Because it goes through the center. So this is going to be 180 degrees. So this part's the part that's left over. So if we do 180 minus 46, and then we subtract 100 as well, that's going to leave us with 34 degrees. So the missing part is 34, and then we add the 100 to it, which is going to be 134. So the measurement of this arc up here is 134 degrees. So our answer is going to be C as in Charlie. So here you can see 74% of you guys got the correct answer for this one. Here are some of the other answer choices. A common mistake last year that not a lot of you guys made, but is that you would subtract from 180, you forget to carry the 1, and so you would get 44 over here instead of 34, and that would give you this answer. Not quite sure. For the 146, it looks like you added these 2 together instead of finding the missing one, so you solved the problem wrong. Anyway, that's number 1. Number 2, what's the measurement of arc BC? Well, if we look here, we have a circumscribed pentagon. So the circle's going all the way around the pentagon. It fits snugly in there. It's also a regular pentagon because all 5 of the sides are congruent. That means the angles on the inside, the inscribed angles, are all going to be congruent. So if we take a pentagon, which has 5 sides, and we take the 360 degrees in the center, and we divide it by 5, that's going to leave us with 72 degrees for each one of these little sections. So if we want to find the arc BC, which is going to be 2 of those, that's going to be so 72 degrees plus another 72 degrees, which is going to give us a total of 144. So this all together is 144 degrees. So the answer should be D as in Delta. So the ones that miss this one, the most missed would be 72. So all you simply forgot to do was to double it. So you found out what one of them was, but BC is not one of them, it's 2 of them. So I think you can clearly see that. All right, number 3 says find the value of X and Y. So this is when we have circumscribed quadrilaterals. So if you notice, the green inscribed angle is going to correspond with this green arc. And the red inscribed angle is going to correspond with this red one. What do you notice about the green and the red arc? That they add up to the full circle, right? So it just cuts a circle into 2 pieces with these 2 points, right? So we know that the red and the green, the arcs are going to add up to 100 or 360, which means the inscribed angles are going to be half of that, which is 180 degrees. So the opposite angles are supplementary. So if we do 180 minus 113, that leaves us with 67 degrees. And the same thing will happen with these two angles. So 180 minus 100 is going to be 80. So our answer is going to be x is equal to 67 and y is equal to 80. So it'd be E as an echo. So most of you guys, it looks like you got that right. I'm not sure what you would have done to get C. Maybe you guys were just guessing on that one, or you took the average of the two or something like that. It looks like for X you did half, and then for this one you did half. Yeah, so it's not necessarily half of the angles, but it's going to be that they add up to 180. So I see what you did wrong on number C, or for answer C. All right, number 4, 54% of us missed this one, so this is pretty tricky. Now, typically we would have done a lot of problems like this on the warm-up, because I know a lot of people missed this, but we didn't really get to that because of the whole different situation that we're in. So we want to know the measurement of BC. So BC is going to be the measurement of arc. Oh, it says the measurement of arc BC is 100, so that's there. What's the measurement of angle AC or BCA? So sometimes you guys mess up the angles. So BCA, where C is the vertice, is going to be this angle right here. So that's what we're trying to solve for. Well, if you notice about ATC or line AC, it's actually a diameter, meaning it's 180 degrees. So the supplement of 100 is going to be 80. So BA is 80. And then the inscribed angle is going to be half of that. So half of 80 is 40. So the angle we're looking for is 40. So looks like there were a lot of guesses going on here. No real pattern to break down. All right, 52% missed number 5. So the chords intersect here. When we have two intersecting chords that are not diameters, then they're not going to be congruent to the opposite arcs here. They're going to be the average of those two. So what we want to do is we want to add these two together, and then we want to divide it by 2. So 105 plus 55 is going to be 160. So this was from your formula sheet, by the way. So half of 60 is going to be 80 degrees. So the average of those two arcs is 80 degrees. So our answer is going to be C as in Charlie. Looks like some of you guys went with the 105. Now, this would be 105 if this was a central angle. So, for instance, if these intersected, I don't know, I'm kind of guessing here, but if it intersected at the center and they were two diameters, then they would be all congruent. But because they don't intersect, two diameters that don't intersect in the center, this is a non-central angle, so you have to use the formula and just take the average. All right, 64% of you guys missed this one. So it says WY is tangent to the circle. Well, if WY is tangent, that means it makes a right angle. So that's the first thing we know. The next thing is we have a right triangle, so we want to solve for one of the missing angles. Well, we can solve for the supplement of this 110 degrees, which is 70. So 70 and 90 is going to be two angles of the triangle, and now we have enough information to solve for the central angle. So adding these two together is going to leave us with 20 because they add up to 180. So our answer is going to be A as in alpha. So it looks like quite a few of you guys said that it was, or you thought it was 70 degrees. Well, you solved for this angle, or maybe you thought these two were congruent, which they're not because it's not isosceles. If they told us it was isosceles, then that would work. But then again, they also still wouldn't add up to 180, so that's not going to work. If it was isosceles right, it would have to be 45, 45, 90. All right, what value of x will make it tangent? So in order for it to be tangent, this would have to be a right angle. We can test what value would make it a right angle by using the converse of the Pythagorean theorem. So the converse of the Pythagorean theorem says that if a squared plus b squared is equal to c squared, then this has to be a right triangle. So simply plug in your parts here. We have a leg of 8, another leg of 15. And we want to solve for the distance for the part there. So put that in the calculator, 8 squared plus 15 squared. We get 289, and then we can solve for d by taking the square root of that, which is going to be 17. So we know this length here is 17. Well, the other part is that this radius is going to be the same as that radius, right? So what's the extended part? The part that's above a sea level, kind of like those problems we were doing earlier, right? With tangents. So if that's going to be 17 and this is 8, we subtract, which leaves us with 9. So this has to be B, is going to be 9. So it looks like there wasn't a lot of pattern in the answers besides that. So if you didn't know how to do it, you just guessed. So now we should know just using the converse of the Pythagorean theorem. All right, number 8, the two segments intersect at point M. What's the length? Okay, so this is another formula that we're using for segments and circles. And it says that AE times EB. So this segment times this one is equal to this segment times this one. So we're just multiplying the parts of the segments. Remember, that's because they actually form two similar triangles. We could have set up proportions, but this is just a shortcut that's easy to remember. So when we set this up, we're going to do 10 times x is equal to 5 times 6, or something close to that. Multiply that, gives us 30, and then we divide by 10, which leaves us with x is equal to 3. So most of you guys got this one right, which is good. And then the rest, I'm guessing you guessed or you forgot the formula. So remember, on the test, you can use the formula sheet. It doesn't really matter anymore if you want. Well, can't really do the retake now because I'm showing you the answers, but most of you guys got that right, so good job. All right, number 9. This is another one of our formulas. So we do the outside times the whole thing is equal to the outside times the whole thing. That's what the formula tells us. So that's going to be 3 times 17 is equal to 5 times n. I'm actually probably going to have to write all this stuff out. Yeah, it's going to be a mess. Sorry, guys, I didn't prepare it. But anyway, 3 times, whoa, that was not what I was looking for. Let me try this again. There we go. All right, so 3 times the whole thing, which is going to be 3 times 20, is going to be equal to 5 times the whole thing, which is 5 times n plus 5. So the first thing we have to do is distribute the 5 through to both of those. So we're going to get 60 is equal to 5n plus 25. When we subtract 25 from both sides, we get 35. So we get 35 is equal to 5n, divide both sides by 5, and we're left with n is equal to 7. So what value of n is going to, whenever we have two intersecting secants, it's going to be 7. So our answer is going to be D as in Delta. All right, so 56% of you guys got that. If not, there were some other answers here. One of those distractors, I forget which one it is when you forget to distribute. So if you did 5n plus 5, then you get 55, so your answer would be 11. So if you got C for an answer, unless you were just guessing, then that's because you forgot to distribute the 5 to the 5 as well. So I put those distractors in there just so we can figure out what you're doing wrong. A common mistake. Number 10, what's the value of x? So on this one, it's the same formula, except now with a tangent, the whole thing is on the outside. So the outside of 10 times the whole thing of 10, so that's going to be 10 squared, which is going to be 10 times 10, or 10 squared is 100. It's going to be equal to the outside of 8 times the whole thing, which is x plus 8. So we have 100 is equal to 8x plus 64. Subtract 64, we get 36. Divide by 8, and we get... So that's 36 divided by 8. I'll put that in the calculator or whatever. We're going to get a decimal, I believe. Yeah, it's 4.5. That's why it wasn't coming to my mind. All right, so it is 4.5. So our answer is going to be A as in alpha. Or sorry, B as in Bravo. All right, so common mistakes on this one. Probably you forgot to distribute again. If you didn't do that, you would subtract 8, getting 92. So what is... 8 divided by 92, yeah, that's the 11.5. So most of the people that miss this problem is because you forgot to distribute the 8 through. Let me see. So yeah, make sure that you do 8 times x. I don't know what's going on here. Yeah, so 8 times x and then 8 times 8 where you get the 64. If not, you would have had 8, and that's what you did wrong. All right, number 11. Find the measurement of x and y. So on this one, we have two inscribed angles, and there's another inscribed angle, but they're both inscribed angles from the same arc. So the arc y here. So if the inscribed angle is 64, we know that the measure of the actual arc, the central angle would be twice that value, which is going to be 28 or 128. So this would be 128. And then the inscribed angle is going to be half of that, which is another one that's 64. So our answers are going to be x is 64, y is 128, which gives us E as an echo. So most of you guys got that right. It looks like the common mistake here for y, looks like you said it was 116. So I'm not sure how you would have got that. Maybe it was just a guess. It was the other one that had this angle of 64. But anyway, remember the relationship between the inscribed angle and the actual arc itself is going to be that it's twice the amount, or half, depending on what direction you're going in with your ratio or scale factor. All right, number 12. Only 22% of you guys missed this, so that's good. What's the length of a diameter in the circle? So this is Thales' theorem. Remember, any right triangle with the length of the hypotenuse or the diameter is going to be found with a third point somewhere on the vertice, or the third point vertice being somewhere on the semicircle. So Pythagorean theorem, and we know this is a diameter, so it's 180 degrees. So the inscribed angle is half of that, which is 90. So it is a right triangle. To find the length of diameter, we just do the Pythagorean theorem. So plug in the values, put that in your calculator, you get 676. Take the square root of that, and that'll give you the length of diameter, which is going to be 26. Nice Pythagorean triple for you. Most of you guys got that right. Looks like if you messed up, you might have just guessed, so that's okay. Also, if we're looking at the diameter, it's got to be larger than the two legs, right? So our answer can't be 13. All right, on number 13, we're going to write the equation of a circle that's tangent to the y-axis with a center at 5 and 3. So centered at 5 and 3, you might graph these out as you go. Tangent to the y-axis. Well, the y-axis is the vertical one going up and down, so it's going to go through this point right here and only intersects the y-axis once. So our circle would look something along the lines of that. So centered here and goes tangent to the y-axis. So first of all, when we plug in our formula, it's x minus h squared plus y minus k squared plus is equal to r squared. The h and the k is a center. So if we plug in the 5 and 3, that's going to be x minus 5 squared plus y minus 3 squared is equal to the radius squared. Well, to find the radius, we can just count over. And we're at x is 5, so it's going to be 5, right? 1, 2, 3, 4, 5. So 5 squared is 25, and that's going to be the equation for our circle, which is C as in Charlie. And most of you guys got that right, which is good. It looks like if you got it wrong, I don't know how you got 9. Oh, yeah, you would have got 9 if you would have used the x-axis instead of the y-axis, right? So if you would have counted down so it's tangent to the x-axis, you just mix those up. So careful, but that was majority of you guys did one or the other. So it looks like you understand the concept. You just got mixed up on that. Write standard form for the following equation. Only 20% of you missed this, which is good. So it looks like the center is going to be at -2 and +1. So plug that in for the h and the k, which is going to be minus a -2 plus y minus 1 squared. What happens when we subtract a negative? It becomes positive, which leaves us with x plus 2 squared plus y minus 1 squared is equal to 16. Now our radius, we could count over or up or down to find the radius, but we go over 2, then 2 more, it's going to be a radius of 4, so 4 squared is 16. So our answer for this one is going to be A as in alpha, which most of you guys got. It looks like the next closest one here, you just switch the values of the negative and positive, so you forgot that in the formula it's x minus h and y minus k, so it's opposite of what the original values are. So that's a common mistake as well. Graph the circle with a radius of 3 and a center at 4, 0. Well, all these have a radius of 3. They're all the same, but the only thing different is the 4 and the 0. So really, do you know how to plot the point 4, 0? It looks like 90% of you guys know how to do that, so that's good. So a common mistake would be A. So on this one, this is actually the point 0, 4, because remember the x portion goes before the y portion, so it's x and y. So that's probably the most common mistake that we saw. But the actual point 40 is going to be D as in delta. So there you go. Looks like you guys did really well on that one. Maybe that problem was too easy. We might change it for next year. 16, the point -7, -6 lies on a circle whose equation is given there. Find the radius. So the best way to do this is to plot it out. So they give you the center. We can derive the center from the equation, which is going to be -4 and -2. Remember, it's opposite of those two. So -4, -2. Point that's on the circle is -7, -6, which is here. Then if we go from the center to any point on the circle, it's going to have a length of the radius. So we just use the Pythagorean theorem. So we're going down 4 and over 5. So plug that into your Pythagorean theorem. It's, of course, Pythagorean triple, which would be 5. So our radius would be 5. So the answer is C as in Charlie. Looks like most of you guys got that right. Looks like here you might have just forgot to take the square root at the end, because remember it's the radius squared is equal to 25. So, but most of you guys got it right, so good job. 17. I'm surprised. A lot of you guys got this right. You didn't have to graph anything out. You just had to plug in the values, and you did a really good job. So that's reassuring. So on this one, they tell us the center is at -1 and +2, and the radius is 3. So all we do is plug in those values. So -1 minus a -1 and y minus 2. And that's going to be equal to, that should be 3 squared. Sorry about that. It'll probably change the answer. But when we subtract a negative, it becomes positive. So that would be, should be 9. There we go. All right, so we have x plus 1 and then y minus 2 and then 9. So the answer would be E as an echo, which most of you guys got that right. Good job. 18 and 19 are kind of two parts. They're asking two different things about the same problem. I kind of like doing these because once you graph it out for one, it's really kind of worth two problems. So really, instead of making one big problem, this gives us an idea of what exactly you're struggling with. So given the endpoints of the diameter of a circle are -4, 2, so -4, +2, and 5, 8, so over 8, or over 5 and up 8. So we can graph that out. We first want to find the center of the circle, which is the midpoint formula. So you can find the average of the x's. So from -4 to 5 is going to be, when we add them together, is +1 divided by 2 is 1/2. You might actually be able to visually see that when you graph it out too. Then to find the average of the y's, we're going from +2 to +8. Added together is 10. Half that would be 5. So the point's going to be 1/2, 5, or 0.5 and 5. So the answer is B as in Bravo. Looks like most everyone got that right. If you graphed it out at all, you would probably be able to guess what the center is just by looking at it. So good job on that. Next part, find the length of the diameter. So we don't want the radius. If we're doing the radius, we do half of it. To do the diameter, we just do the whole thing. So looks like from here to here, we're going over 9 and up 6. So plug that in the Pythagorean theorem, which will give us 117 is the diameter squared. We don't want this diameter squared. We just want the diameter, which is going to be the square root of 117. So that would be E when we take the square root of both sides. Lots of issues on this one. Apparently, maybe you guys just guessed on that one, or I'm not sure how you got 10. That would have been if it was 3, 4. Oh, okay. You might have counted wrong if you counted over 8. So 6 and 8 would give us the value of 10, because that would be a Pythagorean triple. 3, 4, 5 scaled up by 2. So just be careful when you count. We're going from -4 to +5, so that's not a distance of 8, but a distance of 9. That's probably what a lot of you guys got mixed up on that. So that's kind of sad because it was just a counting mistake. All right, number 20, last one, says write the equation of a circle with center at -4, 5, and 3, -2 is a point on the circle. So centered at -4, +5. And if you notice, this one went off the graph a little bit. I forgot to update the graph, so sorry about that. I just extended those lines for an estimate. It doesn't have to be perfect because we're just using the lines as a reference point. And point on the circle is over here. So our circle, or big circle, would look something along the lines of that, just going all the way around. Guess I could actually graph that out if I wanted to. Yeah, so it looks something like that. I know I'm cheating. All right, so we want to find the length of the radius. So it looks like we're going down 7 and over 7. So 7 squared plus 7 squared is going to be 49 and 49, which is going to be 98. Then we take the square root of 98. But if you notice, that's going to be the 98 for the radius squared, so we don't actually need to take the square root with the equation of the circle, which is kind of nice. All right, so our center, they said, was at -4 and 5, so it would be +4 and -5, because remember, it's the opposite. So our answer is D as in delta. Also, if you notice that these in the middle, they're actually minus instead of plus. Now, when we subtract, that's going to be, I'm trying to remember. Yeah, it's not actually a circle. That's I'm trying to think of parabola. I'll just graph it out. Anyway, it would look something along the lines of this. Yeah, so instead of a circle, you'd have that, which I don't teach algebra 2. Shame on me, because I should know what that's called off the top of my head, but I don't. All right, anyway, so I'm pretty sure it's a parabola. So you have two solutions for it, though, like the positive and the minus, so it's not a function, but it wouldn't be a function anyway. Anyway, so we don't use the minus in the formula for a circle, so I'll probably change that for next year where they're all plus. But anyway, our answer would be D as in delta, which would be 46. 46% of you guys got that right, which is good. The most common mistake was 14. Okay, so that would have been if you would have added these together instead of squaring them and then adding them. So if you did 7 plus 7, it would be 14. So I'm not sure if that's what messed you guys up. But anyway, 25 minutes in or 24 minutes in, you guys can go back and look at these problems and figure out which ones you missed to your heart's content. So we're good to go. Overall, we didn't do as well as we normally do, but I kind of expected that. Because the whole distance learning thing just isn't quite the same, and we weren't reviewing and doing our our warm-ups with the problems like we usually do across the board, remediating the ones that we missed. And so this was kind of more like what we'd see on a pop quiz than if we actually prepare for the test. So if we did take the test next, which we're not going to do because we're not giving any grades for the fourth quarter, but I think you guys would be able to fix your mistakes and do really well on it. So don't beat yourself up too much if you didn't do as well as you wanted to. Just refocus in and make sure you're caught up for this next unit for surface area and volume, and we'll see if we can do better on the next one. So thanks for joining me. I'll talk to you guys later.